Everyone, welcome back to SAT Math Question of the Day. So here's our question of the day. Please pause the video, try it yourself, come back, and we'll go over how to do it. Todd purchased beef and chicken from a local butcher for his barbecue. The beef cost $8 a pound and the chicken cost $5 a pound. If he bought a total of 15 pounds of meat and the bill came to $94.50, how many pounds of chicken did he buy? You'll never have this on the SAT, the title of the topic, right? So we should probably hide that. But this is obviously a system of linear equations. There are two unknowns. How many pounds of chicken did he buy and how many pounds of meat did he buy? This is
of beef.
Beef, yeah. This is such a classic two equation, two unknown word problem. It's just like, chances are, if you're in high school, you've seen this question in your life. So this is probably just the standard way of writing it. But you don't have to on the SAT write out the let statement, but we'll do it anyway. Let M be...
No. B.
Let B equal pounds of beef.
Right.
Let C equal number of pounds of chicken. Now, of course, on the SAT, you're not really going to write this out. But it's really
That's why on the SAT, you should use letters that tell you and remind you exactly what the variables stand for, like B and C. Not M, because chicken is a kind of meat, not X and Y.
Oh, you could have done meat and
No. I use B and C.
Okay, fine.
And then keep in mind what is the question.
Of course, we need to solve for C. That's important. So we need there are two unknowns. You need to have two equations. One of them is usually easier than the other. Number of pounds of meat is that B and C basically have to add up to 15. So we'd say B plus C is equal to 15. And now we have to use the fact that the value of the stuff that you buy, the value of buying, if he bought...
the total bill. It tells you the bill.
The total bill. Right.
And the rule for billing is it's a rate. It's a rate. The price per pound is the rate of billed dollars per pound of meat that you buy.
Right.
And so the total price for quantity of chicken is the price per pound of chicken, which is given to you as a number times C.
Right. So the chicken costs $5 a pound. So that's 5 times C, which we don't know. Wait. And they bought 15 pounds of meat.
15 beef.
Fine. Wait a second, though. This is only coming out to be one unknown. Wait, something...
No, hold on. That's why you have to be, don't confuse meat with the unknowns. There's beef and chicken.
Right, yeah, my God.
It's 15 pounds, and the meat means the chicken together with the beef.
I'm so right. Oh, my God. Well, I would have
caught... Why, you're silly. It's why don't confuse. Don't change. It's chicken. Right, and the total of stuff he's buying, the two things he's buying together, the total is the meat.
That is really...
Even though you may think of a chicken isn't meat in the problem.
Right, yeah.
The meat means the chicken or the beef.
Okay.
Okay, go. So now do it right.
Okay, well, first of all, I would have caught the mistake. if you didn't catch it, because this just didn't sound right. It just didn't sound right. Yeah, there was
Well,
some
what if
problem
what
with
if what if they might have given you a different problem? Maybe the problem was he bought $15 worth of chicken. No, he bought $15 worth of meat of beef. They might have said $15 worth of beef.
No,
How much
15
did he pay
pounds.
for the chicken?
Right.
Or
Yeah.
how much did he pay for the chicken? Or how many pounds of chicken did he get?
Yeah. 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 Okay.
Okay. So the thing is, when you're lecturing on a problem and you're guiding people in their thinking, you have to be careful. It's what you say.
Yes. I know. As well, Seth's background is in being a teacher and a professor, so he could speak on his feet. I really can't do it as well. Okay. Okay. Great. Now we have our two equations, two unknowns. Meat. Oh, that is so nasty. Meat. Meat is both chicken and beef. Okay. So now we're home free. We have our systems of equations. We need to solve it. But we need to solve for chicken. We will therefore not waste our time solving for B. We will spend our time wisely solving for chicken. So Seth's using not elimination, a substitution. B is equal to 15 minus C. So then you write 15, and you have to be careful about distributing when you use substitution. 9450. These numbers are very close to each other, so we're not going to be able to approximate. We're actually going to have to get the answer.
We got 8. What's 8 times 15? That's
100.
Or
About
120.
120.
120, and then bring the 8 minus 8c and 5c is 3c. 120 minus 3c equals 94 and a half.
And now everyone has a calculator, so let's get the calculator.
And then you subtract them. You get.
Okay. Yeah.
Well, notice the signs make sense. If when you subtract the 120 from both sides, then the right-hand side becomes negative.
Yep.
And the coefficient of C is negative, so the solution for C is positive, which it should be.
Yep.
So we just take the answer is a third of 120 minus 94 and a half.
Right. Yeah, you just subtract the 120 from both sides, and then you divide by...
Yeah.
Oh, right, and you divide by 3, but the negative signs cancel each other out. Right. Yeah, so that's the answer. So it turns out in the calculator that it's 8.5. That is what the calculator says. So that's the answer. Yeah. I feel sort of recoiling from embarrassment about the meat. 15 pounds of meat. Okay, they always have to make a little twist on the problem. They can't just make it totally, too easy. Okay. But there really is no other way to do this. No other practical way to do this problem. You'd have to set it up as 2 equation, 2 unknown, solve the 2 equation, 2 unknown problem, and get the answer. Okay. So I guess that's it, right?
Oh, yeah.
Yeah, I mean, it's pretty straightforward. 2 equation, 2 unknown problem. So the answer is going to be, hopefully, it's going to be this. Let's see. Okay, and let's see how we answered the question. That is Khan Academy. 7 steps. Okay, let's see what they wrote. Let's start by doing variables. Now, look at this. They did exactly what you did, B and C. Therefore, they're 120. Now, we know beef costs, then B. We know beef costs $8 a pound, and B is represented. Therefore, 8B is the money. Right, similarly, right? So that's what we wrote. The same thing. Since we want to find the chicken, we're going to solve for C. So very standard. And they're using elimination method. Okay, so they're using a slightly different way of solving the 2 equation, 2 unknown problem. And then that just gives you this is standard elimination. We multiply one of the equations by -8. So then you add the 2 equations together. And then you basically get that. And so it's pretty standard. Okay. Oh, look at that. The person's name was Todd. Well, I didn't even notice that. Not relevant. Okay. So I guess that's it. So today is Thursday. Throwback Thursday. So we go back to questions from the old days, let's say 20 years ago, 25 years ago, when these books were a little very old. And to go back to some questions which looked a little different from the questions you see now. This is a question. It probably could still be given on the modern test, but let's see. Let's give it a shot. So, in the figure above, ABCD is a rectangle. That's probably important to know. Rectangle. And the curved path is made up of 16 semicircles, okay, of equal diameter. If the total length of the curved path is 32 pi, the total length of the curved path, we have 6, so I have to annotate. We have 16 of these guys, right? Right? And the total length
of the path.
The total length of the curved path, the total length of the curved path is 32. That means that the length of one of the curves, does that mean that the length of one of the curves is 32 pi divided by 16, which is pi over 2? Is that right? The length of this is pi over 2? Right? Because if the total thing is 32 pi, but you got 16 of those things.
So if the total length of the curve is 32, right? 32 and there are 16 semicircles.
So each one is pi over 2.
So
16. No, each thing is pi over 2.
So each semicircle has a length of the total length is 32 pi, right?
Right.
And there's 16 semicircles. So the length of one semicircle is, wait a minute. No. 16, 32 over 16 is 2.
2 pi. Oh, God.
Yeah.
2 pi.
All right.
That's really stupid. Oh, my God.
Yeah, that's
wow, that was really stupid.
Okay.
You're right. Oh, my God. Wow, that was really dumb. Okay. So that means that half the circumference, so a circumference of a circle is 2 pi r, but half of it is 2 pi r divided by 2 because this is a half circle. So that has to equal 2 pi. Right? So we can solve for r. Seth's watching me. He should.
Pi r equals 2 pi.
Right. So it looks like r is equal to 2.
Pi r equals 2 pi.
So r
equals 2.
R is 2. So
that's
if r is 2,
the radius of the circle.
So that distance there is 2. So this is 2, 2, 2.
That is the radius. Now, so how many so we have to so now we have to figure out the length of each side and multiply the two lengths.
Yeah.
So let's count them. There are two r's for each semicircle. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, 12 semicircles.
Yeah.
So 12r is the length of the long side. R equals 2, so it's 24. And then the short side is 1/3 of the long side. So the area is 24 times 1/3 of 24, right? And so this is 8. So it's 8 times 24 is pretty big. It must be this.
6 times 192.
Yeah.
So this is 4. 4 times 6 is 24. Right. Yeah. Yep.
Yeah.
Yep. 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 Okay. So yeah, we go
So there are
really
many
back.
ways to do this.
There are many ways to do this.
The different in way the difference in ways of doing it are, one difference is you could calculate the diameter of each semicircle.
Right.
And there are two ways to get that. You could calculate the diameter of a you calculate the diameter or the radius by by pairing off these semicircles and observing that the circumference for a given diameter or radius is two of these up and downers, and then the number of up and downers in the whole thing is obviously three on the top, three on the bottom makes 6, and 2 on the sides makes 8. So we have 8 full circles.
Right.
But so one way is to think of it as 8 full circles.
Yeah.
Another way, 16 half circles.
Right.
And then calculate the radius of a half circle, or calculates the radius of a full circle, or the diameter of a half circle, diameter of a full circle. And then whatever it is, if it's the rate, you have to have many ways of calculating how many radii or how many diameters is the long side, and many ways of getting the short side. Right?
Yeah. Yeah, there are a lot of ways to do this problem.
Yeah.
Yeah.
But it's a matter of keeping your wits about you, making sure you use use intermediate quantities consistently.
Yeah.
Yeah.
Yeah. Yeah. Yeah. Okay. So again, not doing too well today. I made this mistake here.
Yeah.
Yeah. Yeah. Yeah. I bet that the answer here, one of these distractors, was probably the answer if you did it that way. Yeah. You'd be off by a factor of 4, right?
Well, they're all multiples of 8.
What's 192 divided by 4?
They're all. This
Yeah,
is 3.
48.
This is 3
Yeah.
times 8. This is 4 times 8.
Yeah.
And this is 4 times 8 is 32. Yeah. What's this one? 6 times 8.
Yeah.
This is 8 times 8, and this is 30. How much is this one? 32. 24 times 8.
But if I kept this mistake here, I would have been off by a factor of 4, right? If I kept this mistake right there, I would have been off by a factor of 4, because instead of 2 pi, it's pi over 2. So I've been off by a factor of 4.
Factor of 4, yeah. That's 6 times 4. Yeah.
Right. So my radius. Yeah.
So you would have been lucky, because you wouldn't have. Your answer wouldn't have been one of the choices.
No, it would have been one of the choices. It would have been. It would have been this one, wouldn't it?
If it would be a quarter too small.
Yeah. Yeah, it would be. It would be. It would be 192 divided by 4, which would be 48.
Yeah.
Yeah. Okay. So, yeah, I mean, it looked like a intimidating problem at first, but in the end, it wasn't too bad. Let's just check the answer. But the chances of us being wrong on this one are very low. Let's just make sure. Okay, math. Section 2 in math. Back then, they only had 2 math sections. Well, they still only have 2 math sections. Oh, yeah, we could see how many people got it right. That's always fun.
Let's see how many people got it right.
Yeah, that's one of the reasons why I was looking at it. Believe it or not, by the way, we are correct. At least they have the same answer we do. Only 14% of the people got it right. Wow. Wonder why. Maybe because there was too much going on, or there were too many parts to it? But only 14% of the people got this right. according to when they give you the answers, they tell you the percent of people who got it right when they gave
Yeah.
the test. Wow. Okay. So, and that's one of the criteria for a Throwback Thursday question is I go back and I look at the table, and whichever questions the fewest people got right, those are the ones we bring in on Throwback Thursday. Okay, so I'm Joel. I have a PhD in mechanical engineering from Columbia University. My brother Seth is a PhD in math from MIT and has been a professor emeritus at SUNY Albany teaching computer science for a load of years. He's now retired. We're here to offer different approaches on how to do SAT math questions. This problem here, the one we just Throwback Thursday question, is they have a lot of different ways to do it. The other one, there really wasn't that many ways to do it. And then we also advocate going to Khan Academy to they have these courses. Right now, almost everyone in the United States is going to take the digital SAT. So go to Khan Academy. They have 600 or 700 math questions that you could practice on that are sanctioned by the SAT people. And that way you know what those, and you've studied basically what's on the test. Then just go to the SAT website and take practice tests, as many as they offer. The more practice tests you take, the better. And the more you try to see the more when you look at it's also advantageous when you do a problem to look at it and see, well, maybe there's more than one way to do it. And very often on the SAT, the way to do it on the SAT is not really the same way you do it in school. Okay, so with all that in mind, on Throwback Thursday, we go back and we look at a test from before 2016 when the tests became more of tests of what you learned in school rather than intelligent tests. So, anything else, Seth?
No.
I think we're done for today. Okay, hope you enjoyed today's Throwback Thursday and regular old two equation, two unknown problem. Okay, everyone, have a great day.